But clearly, there has to be something more, right? So what is missing so far in what I described about a programming language? So I have a document. That's good. Sorry? Implementation, great. So this is just a document. Anyone could write this, this document, but we need to actually implement it in code, right? We need to actually be able to write code. In a way, if again you enjoyed Pain, I could give you a scheme program, and as the human, you could read this spec and start evaluating the scheme program one by one, piece by piece, following these rules like a human would, or like a machine would, and then give me the result, right? Or C++, if you're really, I don't think anyone in the history world has ever done this. If I give you a C++ program, you can read this spec, and in theory, if it's well written enough, you could evaluate the C++ program and print out the output or draw the picture or whatever. But clearly, nobody is doing that by manually, right? So the reason why we have computers is that implementation with an S is that we need to actually implement this programming language somehow. Someone has to write it in code, right? So I say S in plural because most programming languages have more than one implementation. I'll actually just have S, has more than one implementation. So how do you implement a programming language? So if I give you this document for Scheme or whatever, this is C++, wrong one. So if I give you this document, what do you mean by implementing the programming language? One kind of more straightforward way to implement this is to just code up these rules. So, these rules are all just, formal mathematical expressions, right? And you can imagine, you pick your favorite, language you like working in. So let's say you love working in C. And you want to implement Scheme. So the way you do that is you write C code to follow these equations, right? You write C code, for every equation, you make a function in a way in C that does the thing of that equation, right? And if you do that enough and you kind of make it work well enough, then you have let's just say, so this is an implementation. So let's say you have a C program. So this is a C program you write. I'm just saying you pick C just because you know C. You're gonna write a program that takes as input, ooh, my arrows are terrible. That takes as input a text file, right? Just a text file. And this text file has in it just a giant string that's Scheme. So it's, define x5 lambda. my Scheme and handwriting is bad. X, times x, whatever, right? This is Scheme code. So this is just a text file of bytes, right? This is just a piece of text. Your C program will take that text file in, do something with it, and out pops some output to, say, the terminal. It will output whatever the program does. This will output, I don't know, whatever. If you, yeah. That's a good error. Is a good output because I can't write Scheme well, right? So error, or if I wrote this right, you apply it, it's 25 or whatever, right? Does that make sense? So you have a C program you wrote. And that C program implements all these rules, right? You just, write all these rules out, right? You just basically translate word for word every equation into C code. And then when you create a C program, you are able to take in files that represent Scheme programs. This is all Scheme. These are all just text files you slurp in here. And then you run it, and then out pops whatever you want. So this is called an interpreter, or a programming language interpreter. So this is one of the simplest ways to implement programming languages. So one of the implementations is an interpreter, and this is what we just talked about. An interpreter is literally a program that implements the spec, verbatim, and because you implement the spec, you can just feed in any text file that represents that language. If it works right, you print out the result. If it doesn't, print out an error. So why did I write this in C? Why did I write the interpreter in C? The idea here is that you can write this interpreter in anything. This just needs to be some computer code, right? So this interpreter you can write in, if you're, really love Pain, you can write this in assembly language if you want. You can write this in machine code. You can write just ones and zeros into the, into the machine. You can write it in C. You can write it in Python. You can write it in Java. You can write it in Scheme itself. That's exactly right. It's actually not as bad of an idea as you think.
It's very doable.
Yeah, it's actually not as.
Scheme interpreter and scheme.
Yep, it's not a bad idea. It's not actually a bad idea. It's actually a pretty good idea. So there's a whole book about that. So that actually begs the question: how could you possibly write a scheme interpreter in the language itself, right? Because don't you need? Isn't it like a chicken and egg problem, right? Don't you need the interpreter in the first place? Yeah, so the way to solve this problem is that, let's say you're writing an interpreter so the very first scheme interpreter that anyone has ever written in their life, and well, in history, can't be written in Scheme because the language didn't exist yet, right? So let's say the very first Scheme interpreter, Scheme 1.0, was written in C. But now we have a Scheme interpreter, so then you can write Scheme 1.1 in Scheme 1.0. Right? There's no reason why you can't, because you have a language. And then you can write Scheme 1.2 in Scheme 1.1. Like and then that's how stuff actually rolls. So modern implementations of Scheme itself, some of them they have some C code to get you started, just to interface with the operating system. But actually, there are several modern Scheme interpreters that are actually mostly Scheme code. And that's complete. There's no actual contradiction there, because you're using an older version of Scheme to write your new version. Of course, the first Scheme interpreter has to be in another language. So then the next question, how did people write a C interpreter? They wrote it using an old version of C, until they got to assembly, because C didn't exist. And then you start assembly. And then how did people write the first assembly language interpreter? They wrote a machine code, and they keep bootstrapping. So this is an evolutionary process. Good. So this will work. Interpreters work pretty well. They're fairly straightforward to implement. So if you're actually taking a class in programming languages, you might get to the interpreter step. So you study the specification of the language, and you might study how to make an interpreter.